has started. Excellent. So if you have the book, let me say which page it is on. All right. Let me see. Let's see which page you guys can go on. Index notation. So the topic is index notation or laws of indices. And you can go to page. Well, I'll look for the page after, but let's get started. All right. So, head up for me. What is power to power? Okay, excellent. Right. Power to power is essentially, so power to power, and let me give you the notebook if you want to just look at the notes while I'm typing it. All right, there you go. So after class, you can look at the notes exactly. Right. Power to power is where we solve a value given that it is raised to 2 powers. Right? So previously we learned, for example, x to the 2, but now we are saying that this x to the 2, for example, x squared, is to another power. That makes sense. So let's say, for example, give me a random value for x. Any random value. Can you repeat? 2. All right, I heard 2. So 2 squared would have given us what? 4, correct? But what if that 4 was to a power as well? What if we had 4 to the squared as well? So essentially, we could say this is 2 to the 2, right? 2 to the 2 in bracket raised to another power. Right? If you're not on a notebook, let me screen share just to ensure that you understand. All right, here we go. Excellent. Right? So we're saying that this 2 to the 2, which represents 4, is to another power. Right? And we're going to do an example quickly. So the first one we're going to do is called method 1. All right? So method 1. Head up method 1. All right. Let's go here. And let's put method 1. Method 1. Right? Write this for me. Simplify. Sir? Yeah?
What's the topic?
We're talking about power to power. Let me scroll up. Power to power. And the general topic was laws of indices.
Power to power and...
The general topic was laws of indices. So we're continuing from last class. Remember what I said? Yeah. So we're going to learn the first method. So method 1. Simplify this algebraic expression. Algebra essentially means you're solving things that have values just x, right, y, or a. So let me give you an example. Let's solve 5x squared. 5x, right, to a squared value. Should look like this. There you go, 5x squared. Okay? Right. How many 5x do we have? If you have something squared, how many of that thing do you have? If you have x squared, how many x do you have? Let's go back. If we say something is 2, correct? So squared means you have 2 of that thing. So in this case, we have 5x. That means we have 2 of 5x, correct? If it's squared. So we could essentially simplify this to say, simplifying it essentially is saying 5x times 5x. All right, we have 2 5x. It's the first step. All right, there we go. Okay, now, if we have 2 of these 5x, is there anything that is common to both brackets? What I mean by that, can you recognize anything that is in both brackets? Right, because both of them are the same thing. So what we say, when you have 2 of the same things in brackets, you can expand them. Right? Give me a moment, Khalil. Give me a moment. So we're going to expand this to say, for example, this is the same thing to say 5 times 5, right? Then you have x times x. Isn't this saying the same thing? Right? Okay, now let's do our normal calculations. 5 times 5 would have given us 25, right? And x times x would have given us
just x.
No, it wouldn't. Anyone else?
Second.
Yeah, right. Because what do? We say x to the 1 times x to the 1, right? Remember, this is what's always happening. Let's look at this. What do we say that happens when you multiply 2 indices? Right. If you go back in your notes, you'd see where I told you that when multiplying 2 indices with the same base, we add the powers.
That would be answer be 2.
Right. With the same base, comma, we add the powers. Kind of go back in your notes, but remember, you have the notebook. You can go back there as well. We add the powers. So this would have essentially given us 25, right? X to the 1 plus 1, which is essentially, wait, my bad. X to the 1 plus 1, which is essentially 2. 25x to the 2. All right, perfect. So that was this question. Let's go back through the steps. Right? In order to get this to a simpler format, we expanded it. So right for me, right beside each of the steps, we expand. Expanding. Right? When we, after we expanded and we got 5x, we simplified it to say 5 times 5 and x times x. Right? And in this, we grouped like terms. So let me show you the steps correctly. There we go. Okay, and the final step was just to find a value that would have been as an end result. Everybody understand that first method? Okay. All right, good. Now there's another alternative method that we're going to learn quickly. So that was method 1. Let's put everything under method 1. Let's learn the alternative method. All right. All right, excellent. So let's go. Right. Yeah. So what alternative means? Alternative definition basically means different steps to the same solution. Different steps to the same solution. All right. So let's look at this alternative step. It's eerily similar, but there's a key difference, right? In this alternative step, right? When we had 5 times x, let me put it in, when we had, my bad, when we had 5x, right? And we said that is multiplying another 5x. Here's the difference. Right, when we have this, the different method essentially states that we didn't have to say the power were added together. we could have just written it like this. 5 times x times 5 times x. So essentially, write out everything, right? And then you just work across. So this one doesn't involve adding, right? Adding the indices like we did earlier, where we said x plus 1 gives us x squared. This method essentially states where you can just add it from the base itself. So you just simply go 5 times 5 is 25, and then x times x is x squared. So you didn't even need to group it. You just expand it and solve it as is. But the method one is generally the way where you secure most marks. So if you don't remember this method, you can use the alternative step. But try to remember that when you multiply indices, what happens to the power? When you multiply x times x, what happens to the power? Anyone?
Add the power.
Right. Highlight that. We add the powers. All right, let's do one more example. Just to ensure you understand. Let's do a complex example. Let's say we have a value that doesn't even have x. We have a value that has a and b. So here's example 1. No, this is example 2, I should say. We're going to go to example 2.
Can I be excused for a minute?
All right, not a problem. Let's say we have example 2, right? And the example 2 says we have 4a to the 2 power multiplied by b. Let me just write it properly. There we go. All to a power of 3. Right, this is very confusing, right, guys? This looks... All right, so let's go step by step. What is the first thing we need to do? We need to explain how many a's we have when we say a squared. How many a's do we have? 2. So we're gonna say 4 times a times a. Everybody agree?
Yes, sir.
All right, good.
Is it,
All right, hold on.
is it 4 to a square?
No, I'll explain the answer. One moment. So this everybody agrees with here, right? The next part, right, is to remember that the cube is on a step, it's a step up above the squared. So in the previous step, when we had 5x squared, we had 5x and 5x twice, right? Anyone remember that? Where we said basically whatever is in the bracket, we have it twice. Understand? So what do you think will happen when we have 3? Are we still going to have everything in the bracket twice or more?
More.
So someone said 3. I heard 3. So we're going to say basically whatever this is, we're going to have it 3 times. Let's put it 1, 2. There we go. There we go. Simple as that. So let me write exactly what we just did look a while ago. We expanded. Let's put expanding as a power. Right? We write out how many tools we had, right? And then we state how many of the brackets do we have. So you can see a trend here, right? You can write for me. When you see a power on a bracket, whatever is inside of it, the bracket, whatever is inside of that bracket is repeated X amount of time based on the index. And the index is what? The power. Right? So let's simplify this now. Is there anything, well, since it's the same thing 3 times, then there's some things that are in common with each other, correct? So can we group everything that's in common with each other?
Yes, sir.
So we're going to say grouping like terms. There we go. All right. So, Nate, tell me the first thing that's in common with every bracket.
4.
How many of the 4s do we have? 4 times
3.
4 times 4.
Excuse me, would the answer be 64 in this case?
Right, that would be correct. For the 4s, that would be correct. 64. Good job. Now, the next part of it. How many A's do we have? Let's count them.
There are 6 A's.
Right. 1, 2, 3, 4, 5, 6. So we're gonna say A times A. My bad. A times A times A times A times A times A times
Then
A.
the answer be 64 A.
No, hold on. Give me a second. But guys, I'm missing something.
So what about the B?
Exactly. Good job. I was waiting for someone to tell me. I'm missing something because here's what happened. In the bracket, we did not only have 4A squared, we had a B. So let me explain now. What would happen to each bracket if we had one B for each bracket?
I don't know, sir. Can you explain a little more because I don't understand with the B and the A?
All right, let me go over. Khalil, for the first bracket, this bracket is the first one. We have 4A squared B. How many A's do we have?
There are now 6 A's.
No. In this bracket above here. So we're going back to step 1.
There are only 2 A's.
Right. So are you telling me that in every bracket there's going to be 2 A's, correct?
Yes, sir.
How many brackets do we have? How many index do we have as a bracket? 3, right?
3.
So that means for every bracket, we need to have 2 A's, correct, Khalil?
Yes, sir.
Right. Let's look. Do we have 2 A's for every bracket? 1, 2,
Yes, sir.
1, 2, 1, 2. But Khalil, I'm missing something because we didn't write about the B. So how many bracket do we have in the first? I mean, how many B's do we have in the first bracket?
None.
This bracket right here. 1, correct?
Yes, sir.
So that means how many B's should I have for every bracket?
Only 1.
Right. So that means, guys, we need to say 4 times A times B times, there we go, times B.
I will never be solved. Right, sir?
Wait, give me a moment. Times B times B. Right? So that means we would have 3 B's because the power is 3. We would have 6 A's because A times 3 gives us 6. Right? Good. So let's go now. Then what would I add here? If we have all the 4's and all the A's, what would I add here now? We would say,
All the B's.
so we'd say times B, and what?
Times B.
Excellent. Good. Now, time for some addition. Khalil, you told me this is just 64. How did you get 64? By multiplying.
I said when I cube the 4, sir, and I got 64.
Excellent. So we can say 4 cubed gives us 64. Everybody agree?
Yes, sir.
Right. Let's look at the next part. We have A. How many A's do we have?
6.
Right, but remember that in each A, we essentially have A to the power of 1. So whenever you see A times A times A, you're just adding all of those 1s to the A to the 1, and you get 6. So in a sense, it should have been 1 plus 5, which would have given us 6, correct?
Yes, sir. Yes, sir.
Right, good. The next part, how many B's do we have?
3, sir. 3.
So we're going to say B to the 3. So that is essentially our answer. Let me erase the 4 to the 3rd. This would have been our answer. 64, A to the 6, B to the 3. Any questions?
No, sir.
Right, I'm glad you guys are understanding.
So like, what if you had 3 letters, so it's like A to the 2, B to the 4, and C to the 6? What would it be?
It would be the same thing. We will just put the C here, and then based on how many it's raised to, we will just put it in each bracket. So let's do one last example, Khalil, to explain what I mean. But let's use the alternative method for this one. Okay, this is the method 1, and put here, using method 1. Let's use the alternative method, as I stated before. So using alternative method. Let's go here. Using alternative method. Right. Now this alternative method is like a shortcut. Right? So let's look at what happens. Let's write by the question. The question originally was 4A squared, right? B, put this in bracket, to the 3, right? Is this what we had earlier?
Yes, sir.
Right. So this alternative method doesn't even recognize that we need to expand. We just do what we have. So how many of the brackets do we have? We have 3, correct?
Yes, sir.
So the alternative method just says we repeat this bracket 3 times. That's all. Let's put it. So we're going to copy this bracket and we're just going to put it 3 times. That's 1. That's 2. And that's 3. So that's what we do. So we don't look at the power yet. We just put the brackets 3 times. The next thing now is where we simplify. So let's put simplify. Right? How many 4s do we have? We still have 3 4s, correct? So we're going to put 4 times 4 times 4. How many a squared do we have now? So look in each bracket. Tell me how many a squares do you see? 3. So we're going to say times a squared raised to another power of 3. And this rule that we learned earlier is going to come into play. The power rule. One moment. Let me look at this. Let me go here. All right, excellent. Let's go here. Okay, now, can one brilliant person tell me what's the rule when we have a bracket and an index? What do we say we do?
Multiply.
Right. Good job, Jazeel. Let's write that. So when we have brackets to a power, we multiply. I'm glad to know people are reading over. That's excellent. We multiply the 2 index. So in this case, it would have been 3 times 2, correct?
Yes, sir.
Right? But let's not go there as yet. What else do we have? We have actually b's. How many b's do we have?
Only 1.
Are you sure? In every bracket, how many b's?
3.
Right. 3. So we could really say b to the 3 power.
I said, will it be 64, 86 power?
Yeah, so it'll be the same answer, Khalil, but we just use a different step where we don't put every single a. We just use the bracket rule of indices where we just multiply the 2 index to get an easier step to the answer. So this would have really been, let's go here, 64 same way. 3 times 2 is a to the 6, right? And then b to the 3 again. And that's really the alternative step. Okay, good. So that was power to power. Any questions?
Sir, I don't understand. I don't understand. So it's like for method 1, sir, we did not apply to it, sir.
Right. So let me tell you the difference. Write this for me. The difference between method 1 and alternative method. Let's write it. My bad. The difference between the alternative method and the method 1 is simply, right? The alternative method focuses on a shorter approach, right? But sometimes it gets confusing to keep track of the powers. Let me explain. In the previous one, what if you forgot the rule, Jazeel? What if you forgot the rule where you said whenever we have a power to a bracket, we multiply? What if you got that? Then that means the entire thing would be wrong. Because say, for example, someone else might have added 2 plus 3 because they forgot the rule. Understand?
Sure.
So that's why we say use the method 1 in case you forgot one of the rules that we stated earlier. Where method 1 is essentially expand everything and then you just add them individually. right? So I'd like to see the persons who really have a good grasp on this topic use alternative method to really strengthen your laws. But if you really have a little struggle with the topic, use method 1 to ensure that you get your answer correct. All right? Good. So that was the topic. Let's quickly go to now the next topic, which will be, let's go back up here. Multiplying algebraic fractions. That's the next topic. Multiplying algebraic fractions. Let's put this in bold. This is the most important topic of the day. All right, let's put it here. Right. What is this symbol used for multiplying? Let's quickly refresh. What is this symbol used for multiplying? X. Right? So what happens now, right, when we're multiplying algebraic fractions, we have, for example, let me put it here, P, let's put a random value P divided by Q. My bad. P divided by Q. So we have this fraction, right? And essentially, we're going to do the same step as before where we expand what we had. So let's say we didn't just have P, we had P to the third power, right? How would we represent this to solve it? Anyone?
Sir, by using method 1.
Right, which is essentially where we expand, we put out everything we have, right?
Yes, sir.
So we would say, for example, P
times P times P.
Perfect. Good. All divided by Q. Right? Excellent. Now we're going to take this a step further. Right? What if we had another fraction that is to be solved with it? So let's say, not only do we have P cubed divided by Q, we have another fraction, for example, let's put it here, times, right, Q to the cubed power S. We're going to go through it step by step, divided by P R. Right? So let's say we have two fractions that are multiplying. How would we solve this? That's what we're going to go through today. All right? The first step, again, we just simplify. So let me just put a little drawing board right here so you guys can follow along with me. Let's put a drawing board right here. Okay, good. Excellent. So let's take this step by step. Okay? Let's write out what we have for the P cube. Right? We have P. Is someone drawing? Wait. We have P and another P, right? As well as a third one. Then we have all that divided by Q, correct?
Yes, sir.
Yes, sir.
But look at what's happening. We have a multiplication sign. Right, so we have now Q to the cube power. What will we state here? Right, so we'd say Q times what?
Excuse me, sir, but you have a G right there, sir.
No, it's a Q. It's my bad handwriting, my bad. Let's put us a little dash right there. There we go. So we have Q, and Q. All right, good. Let's do this step by step. What else do we have? We have our value of S that is multiplying it. Good. Right. Is there anything else? I think I'm missing something.
PR.
Right.
Divided by PR.
Divided by PR. Excellent. Excellent. Anyone here plays games like Fortnite or whatever? Right? You know in Fortnite that you need to eliminate, or in other games like Candy Crush, you need to eliminate certain things to win. So in other words, to win this fraction or to win this question, we need to eliminate anything that we have twice. Right? Or that could be simplified. So in this question,
Q can be simplified.
right, so we would eliminate some Q's and we would eliminate some P's because we see both of them on both sides of the fraction. Let's write that. Due to the fact we have P's and Q's on both sides of the equation, we can eliminate some when multiplying algebraic fractions. Excellent. Right, let's look at this now. Right, how many q's do we have on the first side? Right, so we could say, for example, this q vanishes and it removes another q right here. So how many? So we take one q away as well up here. Everybody understand? Right? How many p's do we have on the right-hand side? One, correct?
One.
So we could remove this p and remove one up here as well. So we're eliminating as long as we have one on both sides. Let's write that. As long as we have one of each value.
What if we had 3 q's, sir, on that side, sir? What?
Right. If we had, so good question, Khalil. That's an excellent question. Let me just write this first. Let me answer it. So we can eliminate. So Khalil asks, eliminate. What if we had 3 q's here? Well, Khalil, simply, we would just remove each by each. So we'd say, for example, if you had another q here, we would remove one more q here. If we also had another q as well, we would remove the third one as well. So that means that we would have no q's left. Understand? Right, but in this case, we only have one q that compares with the 3. So we only can remove one q. All right, good. Now let's write out what we have remaining. Right? Let's write out what we have remaining. So, answer. How many q's do we have?
We only have 2 q's remaining.
So we're going to say P times P, right? How many q's do we have left?
2, sir.
2. So we're going to say Q times Q. And we didn't touch the S, so we can put back the S. Right? But no. The S was supposed to be in a denominator. My bad. The S was supposed to be here. Right? Oh. No. Don't pay the mind. Don't pay the mind. So we're going to say, for example, we had one more S right here. There we go. Right. Do we have any denominator here? Right. We don't have any denominator because we took away the Q there. Right? Let's go. Right. So let's go to the right-hand side. Do we have any denominator on the right-hand side?
Yes, sir.
We have a R, correct?
Yes, sir. After yes, there will be P times Q times S divided by R, right, sir?
Right. But let's simplify, Khalil. That can be simplified further. Because we can just really state, Khalil, that we have P to the 2 power, right?
Q to the second.
Times Q to the second power times S, all divided by R. Let's look how this looks now. Let's put this here. There we go. Excellent. Excellent. There we go. So that's our answer. So we just did an example using method 1. Let's do another example using method the alternative method quickly. This was method 1. Method 1. That music sounds nice. Let's go here.
What are you playing, sir, in the background?
I'm not sure. For the person that's playing the music, a little bit lower. Thank you. Okay, let's go to the alternative method quickly.
Alternative method. So, like, what's your favorite method, sir? The alternative
I think the alternative method is gonna be some of you guys' favorite, because here's why: it allows you to be creative, right? I know that's not really true, but you understand what I'm saying. It allows you to really use what you learned previously about the different laws of indices and combine them to actually solve a question. So I think the alternative method, once you get comfortable with the topic, you guys will find yourself using the alternative method more, right? So let's quickly do the alternative method to this, right? So let's go back to the question. The question was originally, let's go back to the question, P cubed right? Let's write p cube, p to the cube power, right? Divided by q, right? Multiplied by q to the cube power times s